plain is a broad, relatively flat, or gently undulating landform that dominates many regions of the world. These expansive landscapes are characterized by their minimal elevation changes, typically less than a few hundred meters, and are often found at low altitudes, though some plains exist at higher elevations due to tectonic processes. Plains are one of the Earth's most significant geomorphic features, covering vast areas and playing a critical role in human civilization, agriculture, and ecosystems. They are distinct from rugged terrains like mountains, hills, or plateaus due to their level surfaces, which make them ideal for human activities such as farming, settlement, and infrastructure development. Plains are formed through a variety of geological and environmental processes, including sediment deposition by rivers, wind or glaciers, erosion of higher landforms, or tectonic uplift followed by leveling. They are found on every continent, from the Great Plains of North America to the Indo-Gangetic Plain in South Asia, the Russian Plain in Europe, and the Canterbury Plains in New Zealand. These regions vary in size, climate, and ecological characteristics, but their defining feature is their relatively flat topography, which facilitates human use and supports diverse ecosystems. The significance of plains extends beyond their physical attributes. They have been cradles of human civilization, providing fertile soils for agriculture, flat land for urban development, and accessible routes for transportation. Ancient civilizations, such as those along the Nile, Tigris-Euphrates, and Indus rivers, thrived on plains due to their ability to support large populations through farming. Today, plains remain vital to global food production, housing, and economic activities, but they also face challenges like flooding, erosion, and climate change impacts. In this comprehensive exploration, we will delve into the types of plains, their formation processes, characteristics, importance, and the challenges they face, providing a holistic understanding of these critical landscapes. Type of plain. Plains are classified based on their mode of formation, geological history, and environmental conditions. Each type of plain has unique characteristics that influence its use and ecological role. Below is a detailed overview of the major types of plains, with examples to illustrate their global distribution and significance. Alluvial plains. Alluvial plains are formed by the deposition of sediments, such as silt, sand, clay, and gravel, carried by rivers and streams. Over thousands of years, rivers erode materials from upstream areas and deposit them in lower-lying regions, creating flat, fertile landscapes. These plains are among the most agriculturally productive areas in the world due to their rich, nutrient-laden soils. The Indo-Gangetic Plain, stretching across northern India, Pakistan, and Bangladesh, is a prime example. Formed by the Ganges, Indus, and Brahmaputra rivers, this plain supports over 1 billion people through intensive agriculture, including rice, wheat, and sugarcane cultivation. Similarly, the Mississippi River Plain in the United States is a vital agricultural hub, producing crops like corn and soybeans. Coastal plains. Coastal plains are low-lying areas along coastlines formed by the deposition of sediments from oceans, seas, or rivers. These plains often have gentle slopes and are shaped by wave action, tidal currents, and sediment accumulation. The Atlantic Coastal Plain, extending along the eastern United States from New Jersey to Florida, is a classic example. This plain supports diverse ecosystems, including wetlands and marshes, and is home to major cities like Miami and Savannah. Coastal plains are economically significant, but are highly vulnerable to sea level rise and hurricanes, as seen in regions like the Gulf Coast. Glacial plains. Glacial plains result from the action of glaciers, which deposit materials such as till, unsorted glacial debris, or outwash sorted sediments from meltwater. These plains are common in regions affected by past ice ages, such as Northern Europe and North America. The Great Plains of North America, while partially formed by other processes, include glacial features in their northern sections, where retreating glaciers left behind flat, fertile land. In Iceland, glacial outwash plains, known as sanders, are formed by meltwater from glaciers, creating vast, flat expanses used for grazing and limited agriculture. Structural plains. Structural plains are formed by tectonic processes that uplift large areas of the Earth's crust, followed by erosion that levels the surface. These plains are typically found on stable continental platforms and may be slightly elevated compared to other types. The Russian plain, covering much of European Russia, is an example of a structural plain formed by the gradual erosion of ancient tectonic structures. These plains are often used for agriculture and settlement, though their soils may be less fertile than alluvial plains. Lacustrine plains. Lacustrine plains are formed by the deposition of sediments in ancient lake beds that have since dried up or been drained. These plains are characterized by fine, silty soils and are often highly fertile. The Kashmir Valley in India, once a lake bed, is a lacustrine plain that supports rice cultivation and horticulture. Similarly, parts of the Great Lakes region in North America contain lacustrine plains formed by the retreat of ancient glacial lakes. Lava plains. Lava plains are created by volcanic activity, where lava flows spread across large areas and solidify into flat surfaces. These plains are common in volcanic regions and may have rocky or thin soils, limiting their agricultural potential. The Deccan Plateau in India includes lava plains formed by ancient volcanic eruptions, which have been eroded into relatively flat landscapes. While less fertile, these plains support grazing and some dryland farming. Each type of plain contributes uniquely to the global landscape, influencing human activities and environmental processes in distinct ways. Types of depositional plain. Depositional plains are a subset of plains formed specifically by the accumulation of sediments from various agents, such as water, wind, or ice. These plains are critical for agriculture and human settlement due to their fertile soils and flat terrain. Below is an in-depth look at the types of depositional plains and their formation processes. Alluvial plains. Alluvial plains are formed by the long-term deposition of sediments by rivers. As rivers flow, they carry eroded materials from mountains or highlands and deposit them in lower regions where the water slows down. Over time, these sediments build up, creating expansive flat landscapes. The Indo-Gangetic Plain is a textbook example formed by the sediment-laden waters of the Ganges, Brahmaputra, and Indus rivers. This plain is one of the most densely populated regions in the world, supporting millions of farmers who grow staple crops. Similarly, the Huanghe Yellow River Plain in China, often called the cradle of Chinese civilization, was formed by the deposition of loess and other sediments, making it ideal for agriculture. Floodplains. Floodplains are a specific type of alluvial plain formed by the periodic flooding of rivers. When rivers overflow their banks, they deposit sediments along their margins, creating fertile flat areas. Floodplains are dynamic landscapes, constantly reshaped by flooding events. The Amazon River floodplain in South America supports unique ecosystems in agriculture, while the Nile River floodplain in Egypt has been the backbone of Egyptian agriculture for millennia. However, floodplains are prone to flooding, which can disrupt human activities and infrastructure. Deltaic plains. Deltaic plains form at the mouths of rivers, where sediment-laden water slows as it enters a larger body of water, such as an ocean or sea. The sediments settle, forming fan-shaped deltas that create flat, fertile plains. The Ganges-Brahmaputra Delta in Bangladesh and India is one of the largest deltaic plains in the world, supporting rice cultivation and dense populations. The Mississippi Delta in the United States is another example, known for its rich soils and historical significance in cotton production. Deltaic plains are highly productive but face challenges like subsidence and sea level rise. Glacial outwash plains. Glacial outwash plains, also known as sanders, are formed by the deposition of sediments carried by meltwater from retreating glaciers. As glaciers melt, they release large volumes of water that carry sand, gravel, and other materials, depositing them in flat, expansive plains. In Iceland, sanders are prominent features used for grazing and limited agriculture. In North America, parts of the Midwest, such as areas in Minnesota and Wisconsin, contain outwash plains formed during the retreat of Ice Age glaciers. These plains are often well-drained and support agriculture. Aeolian plains. Aeolian plains are formed by wind-deposited sediments, such as loess, fine, silty material. These plains are common in arid or semi-arid regions, where wind is a dominant erosional and depositional force. The Loess Plateau in China is a classic example, where wind-blown silt has created thick, fertile soils that support intensive agriculture. However, these plains are prone to erosion if vegetation cover is removed, as seen in the Dust Bowl of the 1930s in the Great Plains of the United States, where aeolian processes exacerbated soil loss. Lacustrine plains. Lacustrine plains result from sediment deposition in ancient lake beds that later dry up or are drained. These plains are characterized by fine, silty soils that are often highly fertile. The Kashmir Valley, once a lake, is a lacustrine plain that supports rice and fruit cultivation. In North America, the Great Salt Lake in Utah has left behind lacustrine plains as its waters receded, creating flat landscapes used for agriculture and settlement. These plains are valuable, but may face challenges like waterlogging due to poor drainage. Characteristics of plain. Plains are defined by a set of distinct characteristics that make them unique among landforms. These features influence their ecological, economic, and cultural significance. Flat or gently rolling terrain. The most defining characteristic of plains is their flat or gently undulating topography. Elevation changes are minimal, typically less than a few hundred meters, making plains ideal for agriculture, settlement, and transportation. For example, the Great Plains of North America stretch for thousands of kilometers with only gradual changes in elevation, creating a uniform landscape. Fertile soils. Many plains, particularly alluvial, flood, and loess plains, have highly fertile soils due to the deposition of nutrient-rich sediments. The Indo-Gangetic Plains' silty soils support intensive agriculture, while the loess plateau's fine soils are ideal for wheat and millet cultivation. However, soil fertility varies, with lava plains often having thinner, less fertile soils. Low altitude. Plains are typically found at low altitudes, often near sea level, though structural plains may be slightly elevated. Coastal plains, like those along the Gulf of Mexico, are at or near sea level, making them vulnerable to flooding. Higher elevation plains, like the Russian plain, are still relatively flat compared to surrounding regions. Wide expanse. Plains often cover vast areas, stretching hundreds or thousands of kilometers. The Russian plain, for instance, spans much of Eastern Europe, while the Great Plains cover parts of 10 U.S. states and 3 Canadian provinces. This vastness makes plains critical for large-scale agriculture and settlement. Water features. Due to their low relief and sediment deposition processes, plains often host rivers, streams, wetlands, or aquifers. The Mississippi River plain is crisscrossed by tributaries, while the Everglades in Florida, a coastal plain, is a vast wetland. These water features support agriculture, ecosystems, and human settlements. Vegetation. The vegetation of plains varies widely based on climate and soil. Grasslands dominate many plains, such as the prairies of North America or the steppes of Central Asia, while alluvial plains may support forests or agricultural fields. The Pantanal in South America, a floodplain plain, is a biodiversity hotspot with wetlands and grasslands. Importance of plain. Plains are among the most critical landscapes for human civilization and environmental systems. Their importance spans agriculture, settlement, transportation, and biodiversity. Agriculture. Plains, especially alluvial and loess plains, are the world's breadbaskets. Their fertile soils and flat terrain make them ideal for large-scale farming. The Indo-Gangetic Plain produces much of South Asia's rice and wheat, while the Great Plains are a global leader in corn, wheat, and soybean production. These regions feed billions of people and are vital to global food security. Settlement. The flat terrain of plains facilitates the construction of cities, towns, and infrastructure. Major urban centers like Delhi, Cairo, and Buenos Aires are located on plains, benefiting from easy access to resources and transportation. Plains support high population densities due to their suitability for housing and urban development. Transportation. Plains provide ideal conditions for building roads, railways, and airports due to their level surfaces. The Great Plains, for example, are crisscrossed by major highways and rail lines, connecting agricultural regions to markets. Coastal plains often host ports, facilitating global trade, as seen in cities like Shanghai on the North China Plain. Water resources. Plains often contain rivers, aquifers, and wetlands, which are critical for irrigation, drinking water, and industrial use. The Nile River Plain supports Egypt's agriculture through irrigation, while the Ogallala Aquifer beneath the Great Plains provides water for farming in the United States. Wetlands and plains, like the Everglades, also purify water and support ecosystems. Economic activities. Plains support diverse economic activities including agriculture, mining, and trade. Structural plains, like those in Australia, may contain mineral deposits, while coastal plains host fishing and tourism industries. The accessibility of plains makes them hubs for commerce and industry. Biodiversity. Plains support diverse ecosystems, from grasslands to wetlands. The Pantanal in Brazil, a floodplain plain, is one of the world's largest tropical wetlands, hosting jaguars, caimans, and countless bird species. Grasslands in the Great Plains support bison and prairie dogs, contributing to global biodiversity. 6. Problems of plain. Despite their importance, plains face numerous challenges that threaten their sustainability and human use. Flooding. Low-lying plains, particularly floodplains and coastal plains, are highly susceptible to flooding. The Ganges-Brahmaputra Delta in Bangladesh experiences annual floods, causing loss of life, property damage, and agricultural disruption. Coastal plains like those in Louisiana face storm surges from hurricanes, exacerbating flood risks. Soil erosion. Intensive agriculture and deforestation can lead to soil erosion in plains, particularly in aeolian and alluvial plains. The Dust Bowl in the Great Plains during the 1930s demonstrated how poor land management could devastate fertile soils, leading to economic and environmental crises. Erosion reduces soil fertility and agricultural productivity. Waterlogging. Poor drainage in some plains, especially lacustrine and floodplain plains, can lead to waterlogging, where water accumulates in the soil, damaging crops and infrastructure. The Punjab region in India and Pakistan faces waterlogging issues due to over-irrigation, affecting agricultural yields. Urban sprawl. The flat terrain of plains encourages rapid urban expansion, often at the expense of farmland and natural habitats. The North China Plain has seen significant loss of agricultural land to urbanization, threatening food security. Similarly, coastal plains like those in Florida face habitat loss due to development. Vulnerability to climate change. Coastal plains are particularly vulnerable to climate change, facing risks from sea level rise, storm surges, and salinization of soils. The Ganges-Brahmaputra Delta is at risk of inundation, threatening millions of people. Inland plains, like the Great Plains, may face increased drought and heat waves, impacting agriculture. Monoculture risks. Heavy reliance on single crops, such as wheat or corn, in plains can deplete soils and increase vulnerability to pests and diseases. The Great Plains' focus on monoculture has led to soil nutrient loss, requiring heavy fertilizer use, which can pollute water sources. Natural disasters. Some plains are prone to specific natural disasters. The Great Plains are known as Tornado Alley due to frequent tornadoes, which can destroy crops and infrastructure. Coastal plains face hurricanes as seen in the Gulf Coast, where storms like Hurricane Katrina cause widespread devastation. Conclusion. Plains are among the most vital landscapes on Earth, shaping human civilization, supporting global food production, and hosting diverse ecosystems. Their flat terrain, fertile soils, and accessibility make them ideal for agriculture, settlement, and transportation, but they also face significant challenges, including flooding, erosion, and climate change impacts. Understanding the types, characteristics, importance, and problems of plains is crucial for managing these landscapes sustainably, ensuring they continue to support human and environmental needs for generations to come.